Let's do Brahmanad. Om. Om. Shanti. 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 Swastha. Dear student, previous class I discussed about the introduction of science, introduction of chemistry, matter, types of matter, properties of matter, symbol, formula, chemical equation, like that. Now I will discuss about the atomic mass. Atomic mass ର meaning ହେଲା ପାରମାଣବିକ ବସ୍ତୁତ୍ୱ. Before going to the atomic mass, I will teach you some daily life example. Suppose I will ask you what is the weight of an elephant. Generally ଆମେ କହିପାରିବା 10,000 kilogram. Suppose हम कहो what is the weight of buffalo. Generally हम कहवा 1000 kilogram. Suppose मनकर हम धरि नबा एतिक तार weight बोली. से बळे हम कहवा what is the weight of man, तो हम कहवा 100 kilogram. Weight of a dog कहवा ताले हमें कहवा generally aroundly 40 kilogram. Weight of हम यदि hen कहवा ताले हम कहवा 5 kilogram. Weight of a mouse यदि कहवा तो half kilogram कहवा. Every living organism having a particular weight. It is very difficult to remember the weight of all the living creature. हमको बहुत difficult है समस्तिंगर weight मने रखिया पाए. सिद्धि पाए हमें गोटे न्यू टर्म व्यवहार करिथा जनरली गुण. कौन न्यू टर्म ना हमें जन को अन्य जन सहित कंपैरिजन करिथा. फॉर एग्जांपल मैन को एलिफेंट. मैन रो वेट थारो एलिफेंट 100 गुण रे बड़. एटा मन रखेटा इजी, किंतु 10,000 किलोग्राम रखेटा डिफिकल्ट. मैन थारो बफालो रो वेट होची 10 गुण रे बड़. किंबा डॉग रो मध्ये गोटे पर्टिकुलर गुण रे छोटो बोली कहि परिबा. सेबळे हेन रो वेट मैन रो वेट थारो एतिकी गुण रे निर्दिष्ट गोटे गुण रे छोटो बोली कहि परिबा. जाहाकु भी जा सहित कंपैरिजन करिकी मने रखिले हमें समस्तिंगर वेट टाको इजीली हमें मने रखि परिबा. हमें एमिति जनक द्वारा कंपैरिजन करिबा जोटा कि समस्तिंको गोटे निर्दिष्ट गुण रे परिप्रकाश करि पारुथिबो. यदि हमें माउस को एलिफेंट सहित कंपेयर करिबा, माउस को बफालो सहित कंपेयर करिबा, माउस रो वेट को मैन सहित कंपेयर करिबा, ताले ये बेसी गुण हे जिवो. फॉर एग्जांपल माउस को एलिफेंट रो यदि वेट हिसाब हम यदि कंपेयर करिबा, माउस रो वेट एलिफेंट रो वेट अपेक्षा केते प्राय 20,000 गुण छोटो बोली कहबा. हमर एम कोन थिला? हमर एम थिला जे आमे वेट गुडा को इजीली केमती मन रखि परिबा, इजीली केमती कैलकुलेशन रे भाग करि परिबा, पार्टिसिपेट करि परिबा से डिजिट गुडा को इजीली केमती लिखि परिबा. किंतु आमे माउस को यदि रो वेट को एलिफेंट रो वेट कंपेयर करिबा ताले 10,000 करे से 20,000 आसला, तो आउरी बड़ डिजिट हला. पुनी आउथरे हमको सेही डिफिकल्टनेस ही आसीबो. तो आमे ए भीतर जण को एमती गोटे फिक्स करि रखि दबा जाके कि समस्तिक द्वारा आमे कंपैरिजन करि परिबा, जा फल रे समस्तिक वेट को आमे इजीली मने रखि परिबा. सपोज मु कहबी मैन को कंपेयर करिबा. समस्त मैन को भगार सहित रिलेटेड मैन रो वेट सते किंतु विभिन्न क्रिएचर जो लिविंग क्रिएचर विषय मे भी से धारणा थाई पारे न थाई पारे किंतु मेन रो वेट को समझते इजीली मन रखि पारे तेणु मु मेन को कौन कली एलिफेंट सहित कंपेयर कली मेन को बोफाल सहित कंपेयर कली मेन को डॉग सहित मेन को हेन सहित मेन को माउस सहित और भी अनेक गुडी लिविंग प्राणी सहित आमे कंपैरिजन करि परिया यदि मेन रो वेट को कंपैरिजन कला पर यदि किछि अधिक रु अधिक डिफिकल्ट हैला ताले मेन रो वेट को कंपैरिजन करिया किछि आवश्यक नै नेक्स्ट आमे आउ जन को सिलेक्ट करिवा जा फल रे ताहार वेट को नै कि आमे कंपैरिजन करले हमको इजी लागुथिबो सेही वेट को आमे नै कि अन्य को कंपेयर करिवा आमे यदि मेन को कंपेयर करिया एलिफेंट सेतिरे तो माउस अपेक्षा वेरी इजी हबो एज कंपेयर टू माउस मेन रो वेट को आमे यदि अन्य समस्या सेतिरे कंपेयर करिवा ताले भलो हबो मे भी एमाने सब छोट हबे गुण रे एमाने सब बड़ हबे गुण रे ये होची हमर सिंपलीफिकेशन ये होची हमर डेली लाइफ एग्जांपल कथा जेमति प्रत्येक लिविंग क्रिएचर को आमे कहले जे मेन सेतिरे कंपेयर करले हमहु भलो इजी हबो से भलिया आमे बर्तमान देखिबा एटम कथा रिमेंबर एवरी एटम हैव ए पर्टिकुलर वेट मेन हो डॉग हो हेन हो माउस हो एमान को वेट को आमे निकिति रे मेजरमेंट करि परिबा किंतु एटम रो वेट को आमे वेट मशीन द्वारा मेजर करि परिबा नहीं नॉर्मल जो वेट मशीन अछि ता द्वारा हमें मेजर करबा इट इज वेरी डिफिकल्ट टू मेजर सेति पई वी जनरली यूज स्पेक्ट्रोमीटर मास स्पेक्ट्रोमीटर ए मास स्पेक्ट्रोमीटर द्वारा हमें प्रत्येक एटम रो वेट को हमें मेजरमेंट करि परिबा बाय द हेल्प ऑफ मास स्पेक्ट्रोमीटर we can able to measure the weight of an atom experimentally समस्त atom ro weight we can measure by the help of mass spectrometer experimentally it is seen that the mass of an oxygen atom is 2.656 into 10 to the minus 23 gram similarly mass of an carbon atom is 1.9923 into 10 to the minus 23 gram. Similarly, weight of an atom of hydrogen is 1.67328 into 10 to the minus 24 gram. Weight of an atom of nitrogen is 2.324 into 10 to the minus 23 gram. Weight of an atom of helium is 6.64 into 10 to the minus 24 gram. Every atom have a particular weight which is measured by the help of mass spectrometer. Look at that. These values, these digits are very complicated. As a result, it is very difficult to remember. It is very difficult to calculate. It is very difficult to write. Many problems created by these digits. So, to remember or to write or to explain these digits, we generally use a new term that is your atomic mass instead of exact mass of an atom. गोटे atom रा exact mass होचे गुडा कपिले किंतु एटॉमिक मास एक्जेक्ट नहीं एटॉमिक मास होची गोटे कंपैरिजन मास जेमति मु कहले मेन को एलिफेंट सहित कंपेयर करिवा मेन को बोफाल सहित कंपेयर करिवा मेन को डॉग सहित कंपेयर करी कि जो गोटे गुण बाहर गले सिमिलरली एटॉमिक मास और इट इज आल्सो कॉल्ड रिलेटिव एटॉमिक मास यू नो वेरी वेल एटॉमिक मास ऑफ ऑक्सीजन इज योर 16 AU every atom having a particular atomic mass just like oxygen having atomic mass 16 AU, nitrogen having 14 AU, hydrogen having 1.008 AU which is nearly equal to 1 AU. Similarly, carbon having atomic mass is 12 AU, helium having atomic mass is
4 AMU.
ଯେମିତି ଆମେ men को elephant ସହିତ comparison କଲେ, similarly these value are obtained by comparing with the one value to other value. We know that the atomic mass of oxygen is 16 AMU. This is nothing but it is a relative number. Just like आमे जेमती men को elephant सहित comparison करिवा, केमती comparison करिवा, आमे कोन करछे ना 10,000 नोचे divide by 100 तो आमे पाइ जाउछे 100 गुण बोली पाइ परछे। ता अर्थ एलिफेंट रो वेट मेन रो वेट थारो 100 गुण रे बड़ बोली कहउछे। सिमिलरली 16 एम मध्ये सेही बोली आएगा। तो 16 एम केमती हमें पाइबा बाय टेकिंग दिस वैल्यू एंड आल्सो it is bound to take this value 1.66 into 10 to the minus 24 gram. By this value we can able to find out the atomic mass of every atom. That means I can write 16 AMU equal to 2.656 into 10 to the minus 23 gram divide by 1.66 into 10 to the minus 24 gram. For calculation of atomic mass of oxygen, we generally use
the exact mass of an atom of oxygen
and this value. Similarly, suppose I want to calculate the atomic mass of nitrogen. Then we use generally
the exact mass of an atom of nitrogen
and this value. That means for nitrogen case we can write like this: 14 AMU equal to 2.324 into 10 to the minus 23 gram divided by 1.66 into 10 to the minus 24 gram. For the calculation of atomic mass of every atom, we generally use this value. Just like आमे जेमती एठारे गुण बाहर गले से भलिया आमे मध्य atomic mass को ए वैल्यू द्वारा में बाहर करि परिबा. Generally we know about the atomic mass of every element. The atomic mass of hydrogen is 1.008. The atomic mass of nitrogen 14. The atomic mass of helium 4. The atomic mass of carbon 12, like this. But this value can be calculated by the help of
exact mass of an atom
and by this value. Finally, I can write for oxygen 16 AMU equal to 2.656 into 10 to the minus 23 gram divided by 1.66 into 10 to the minus 24 gram. For nitrogen, I can write 14 AMU equal to 2.324 into minus 23 gram divided by 1.66 into 10 to the minus 24 gram. Similarly, for carbon, I can write 12 AMU equal to 1.9923 into 10 to the minus 23 gram divided by 1.66 into 10 to the minus 24 gram. From this data it is clear that atomic mass equal to mass of one atom of the element divided by 1.66 into 10 to the minus remember this value, that means see 1.66 into 10 to the minus 24 gram equal to mass of an atom of C12 divided by 12. Now put the value of mass of an atom of C12 and also check whether it is equal to 1.66 into 10 to the minus 24 gram or not. We know that mass of an atom of C12 is 1.9923 into 10 to the minus 23 gram. Now put this value here. That means I can write 1.66 into 10 to the minus 24 gram equal to 1.9923 into 10 to the minus 23 gram divided by 12. From this data, it is clear that atomic mass equal to mass of an atom of the element divided by 1 by 12 into mass of an atom of C12 isotopes. You can ask a question here, why it is bound to use the mass of an atom of C12? Why you cannot use the mass of an atom of other element? That means why you cannot use the mass of an atom of oxygen, like your hydrogen, like you can also think about the nitrogen. Why such type of mass cannot be used for the calculation of atomic mass? The answer is very simple. By using this value, we can able to find a simple value which can be easily remembered, which can be easily calculated, which can be easily explained, or which can be easily write. From this relation, it is clear that atomic mass of an atom of the element is the number of times an atom of that element is heavier than 1 by 12 mass of an atom of C12 isotopes. This is the definition of atomic mass. How many number of times an atom is heavier than 1 by 12 mass of an atom of C12 isotope? That is your atomic mass. Kete gunare siye 1 by 12 mass of an atom of C12 isotope tharu adhiko ojoniya. That is called atomic mass. Here I can write mathematically atomic mass equal to mass of an atom of the element divided by 1 by 12 into mass of an atom of C12 isotopes. That means I can write atomic mass equal to 12 into mass of an atom of the element divided by mass of an atom of C12 isotopes. We know that atomic mass equal to 12 into mass of an atom of the element divided by mass of then I can write atomic mass of oxygen atom equal to 12 into mass of an atom of oxygen element divided by mass of an atom of C12 isotopes. Remember an important point: the mass of an atom of oxygen element and mass of an atom of C12 isotope can be determined by the help of mass spectrometer. It is seen that the mass of an atom of oxygen element is 2.656 into 10 to the minus 23 gram, and also it is seen that mass of an atom of C12 isotope is 1.9923 into 10 to the minus 23 gram. After solving, it is found that atomic mass of oxygen atom equal to 15.972 AMU, which is nearly equal to 16 AMU. Instead of 16 AMU, we can also write 16U. AMU means atomic mass unit, U means unified mass. From this value, it is clear that mass of an atom of oxygen is 16 times heavier than 1 by 12 of mass of an atom of C12. Similarly, you can find the atomic mass of nitrogen, which is equal to 14 AMU. 14 AMU means mass of an atom of nitrogen is 14 times heavier than 1 by 12 of mass of an atom of C12 isotope. Suppose I want to find out the atomic mass of carbon, then I can write atomic mass of carbon equal to
12 into 1.9923 into 10 to the power minus 23 gram divided by 1.9923 into 10 to the minus 23 gram. Look at that, I can cancel these two terms. As a result, I can write atomic mass of carbon equal to 12. This is your exact mass of a carbon atom.
From this, it is clear that atomic mass of carbon equal to 12 AMU. That means the atomic mass of carbon is exactly taken as 12 AMU. From this discussion, it is clear that atomic mass of oxygen equal to 16 AMU. But remember,
Exact mass of an atom
of oxygen equal to 2.656 into 10 to the minus 23 gram. This value is calculated by the help of mass spectrometer, but remember, this value is calculated by comparing this value with the 1.66 into 10 to the minus 24 gram, which is equal to mass of an atom of C12 divided by 12. Here I can write 16 AMU equal to 16 into 1 AMU. If I will multiply the 16 with this value, then I can find 2.656 into 10 to the minus 23 gram. That means I can write 16 into 1 mu equal to 16 into 1.66 into 10 to the minus 24 gram equal to 2.656 into 10 to the minus 23 gram. Similarly, in case of nitrogen, I can write 14 into 1 mu equal to 14 into 1.66 into 10 to the minus 24 gram equal to 2.324 into 10 to the minus 23 gram. From this it is clear that 1 mu equal to 1.66 into 10 to the minus 24 gram, which is equal to mass of an atom of C12 divided by 12. Suppose I want to define what is 1 mu, then I can define 1 mu is equal to 1 by 12th of mass of an atom of C12 isotope. From this it is clear that actual mass of an atom equal to atomic mass of that atom in mu into 1.66 into 10 to the minus 24 gram. Suppose I want to know about actual mass of any atom, then I can multiply 1.66 into 10 to the minus 24 gram with the atomic mass of that atom in mu. Remember an important point, atomic mass expressed in gram is called gram atomic mass. For example, atomic mass of oxygen equal to 16 mu, that means gram atomic mass of oxygen atom equal to 16 gram. If you will think about the atomic mass of nitrogen equal to 14 mu, suppose I want to find out the gram atomic mass of nitrogen atom, then I can write gram atomic mass of nitrogen atom equal to 14 gram. Just change this mu word and write gm word. But remember, there is a difference between gram atomic mass of oxygen atom and mass of an atom of oxygen atom. Gram atomic mass of oxygen atom equal to 16 gram means weight of 6.022 into 10 to the 23 oxygen atom equal to 16 gram. This is your Avogadro number. Remember an important point, gram atomic mass is also called gram atom. Gram atom is a single word. Don't think that this atom word indicates to any atom of any element. This atom word clearly attached with this word. That means I can write 1 gram atomic mass or 1 gram atom of oxygen atom equal to 16 gram. Remember, these atom word do not link with this oxygen element. These atom word clearly link with this oxygen element. Similarly, 2 gram atom of oxygen atom equal to 2 into 16 gram, that is 32 gram. This word, that means gram atom word, clearly indicate that this oxygen atom must be belongs to atom, but it do not belongs to the molecule. Sometimes the atom word
will have written or may not have written.
By following this word, we can easily understand that the oxygen must be belongs to atom, not belongs to molecule. Suppose here 2 gram molecule is written, then it is bound to understand that this oxygen related to the molecule. Because like gram atomic mass, gram molecular mass is also present. I will teach gram molecular mass in next topic. From this it is clear that 1 gram atom of oxygen is not equal to 1 gram of oxygen atom. This is your weight of 6.022 into 10^23 oxygen atom. That means for this term I can write weight of 6.022 into 10^23 oxygen atom. That means 1 gram atom of oxygen is equal to weight of 6.022 into 10^23 oxygen atom. It is bound to remember the atomic mass of different atom, because by the help of atomic mass we can able to calculate the molecular mass of a molecule. Remember some important formula for the calculation of atomic mass. First one is atomic mass equal to equivalent mass into valency. I will teach you about equivalent mass in next topic. Next formula is your atomic mass equal to 2 into vapor density divided by atomicity. Remember, atomicity means number of atoms in a molecule. For example, atomicity of oxygen in O3 equal to 3, atomicity of oxygen in O2 equal to 2, atomicity of oxygen in CO2 equal to 2. Similarly, atomicity of carbon in CO2 equal to 1. Next is your vapor density. Vapor density equal to weight of XML of a gas at NTP divided by weight of XML of hydrogen at NTP. NTP means normal temperature and pressure. Suppose I want to find out the vapor density of 20 ml of nitrogen gas at NTP. Then what will be the formula? Vapor density of nitrogen equal to weight of 20 ml of nitrogen gas at NTP divided by weight of 20 ml of hydrogen at NTP. Similarly, suppose I want to find out vapor density of 100 ml of oxygen at NTP, then what will be the formula? Vapor density of oxygen equal to weight of 100 ml of oxygen at NTP divided by weight of 100 ml of hydrogen at NTP. Next is your Dulong's-Petit's method. According to this method, approximate atomic mass equal to 6.4 divided by specific heat. This formula is only applicable for solid elements except beryllium, boron, carbon and silicon. Next I will explain what is the meaning of specific heat. required to raise 1 degree temperature of a body having unit mass. Next I will discuss about the molecular mass. We know that atomic mass of an atom equal to mass of that atom of the element divided by 1 by 12 into mass of an atom of C12 isotopes. Similarly, I can write molecular mass of a molecule equal to mass of that molecule of the substance divided by 1 by 12 into mass of an atom of C12 isotopes. From this relation, I can write the definition of molecular mass. The molecular mass of a molecule of the substance is the number of times a molecule of that substance is heavier than that of 1 by 12 of the mass of an atom of C12. This is the definition of molecular mass. Remember an important point, molecular mass expressed in gram is called gram molecular mass or gram molecule. Suppose I will take an example, molecular mass of methane is 16 mu. Then gram molecular mass of methane equal to 16 gram. Remember, the 16 gram is the weight of 6.022 into 10 to the 23 CH4 molecule. Gram molecular mass is also called gram molecule. That means I can write 1 gram molecule of CH4 molecule equal to 16 gram. Similarly, 2 gram molecule of CH4 molecule equal to 32 gram. Like that, you can also find 3 gram molecule of CH4, 4 gram molecule of CH4. Next, I will give some important formula to calculate the molecular mass. First point is molecular mass equal to 2 into vapor density. Second point is the algebraic sum of atomic masses of different atoms present in a molecule is equal to molecular mass of that molecule. For example, molecular mass of Na2CO3 equal to 2 into atomic mass of sodium plus 1 into atomic mass of carbon plus 3 into atomic mass of oxygen. We know that atomic mass of sodium is your 23 and atomic mass of carbon is your 12. Again we know that atomic mass of oxygen is your 16. By solving we can able to find out the molecular mass of Na2CO3 which is equal to 106 AMU. Like this, you can also able to find out the molecular mass of H2SO4. You can also find the molecular mass of NaHCO3 like this. Next formula is your R1 by R2 equal to root over of M2 by M1 equal to root over of D2 by D1 equal to root over of capital D2 by capital D1 equal to T2 by T1 equal to V1 by V2. Here R1 is equal to rate of diffusion of gas 1, R2 is the rate of diffusion of gas 2, M1 is the molecular mass of gas 1, M2 is the molecular mass of gas 2, D1 is the density of gas 1, D2 is the density of gas 2, capital D1 is the vapor density of gas 1, capital D2 equal to vapor density of gas 2, T1 is the time taken for diffusion of gas 1, T2 is the time taken for diffusion of gas 2, V1 is the velocity of gas 1, V2 is the velocity of gas 2. This equation is derived from Gram's law of diffusion. This method is called diffusion method. Next is your gram molecular volume method. This method is also used to calculate the molecular mass. Molecular mass means anavika vastutva. According to this method, gram molecular volume of any gas at NTP equal to 22.4 liter. Here NTP means normal temperature and pressure. Temperature is your 273 Kelvin, pressure is your 760 mmHg. From this it is clear that if I will take a gram molecular mass of a gas in a tank and the pressure of the gas is 760 mmHg and temperature is 273 Kelvin, then the gas must have volume 22.4 liter. On the other hand, if you will take 22.4 liter of any gas and the gas having temperature 273 Kelvin and pressure 760 mmHg, then the mass of the gas is equal to its gram molecular mass. Suppose I will take nitrogen gas. Suppose the volume of nitrogen gas is 22.4 liter and the pressure of the nitrogen gas is 760 mmHg and the temperature of nitrogen gas is 273 Kelvin. Then the nitrogen gas is taken in the container must be equal to 28 gram because 28 gram is the gram molecular mass of nitrogen molecule, because the nitrogen having molecular mass 28 AMU. From this method I can write a formula: molecular mass equal to weight of the gas divided by volume of the gas in liter at NTP into 22.4 liter. This is your formula by which we can able to find out the molecular mass of any gas. This formula also can be written: molecular mass equal to weight of the gas in gram divided by volume of the gas in ml at NTP into 22,400. That is must be taken in ml. Suppose I will do a problem: 0.842 gram of a gas having pressure 760 mm Hg and temperature 273 Kelvin occupies a volume of 364 ml. Find the molecular mass of the gas. Here the weight of the gas is 0.842 gram. Here the volume of the gas is 364 ml. Here I can write the formula gram molecular mass equal to weight of the gas in gram divided by volume of the gas in liter at NTP into 22.4. Here also I can write gram molecular mass equal to weight of the gas in gram divided by volume of the gas in ml at NTP into 22,400. Now apply one formula here. I can write gram molecular mass equal to 0.842 gram divided by volume of the gas in ml, that is 364 ml. So here I can write 364 ml into 22,400 ml. By solving, I can write gram molecular mass equal to 51.81 gram. Therefore, molecular mass equal to 51.81 AMU. Next, I will explain about the equivalent mass. Suppose I will take some example. Magnesium plus H2SO4 gives a magnesium sulfate plus hydrogen gas. Similarly, I can take magnesium plus hydrogen gives a magnesium hydrate. Magnesium plus oxygen gives a magnesium oxide. Magnesium plus chlorine gives a magnesium chloride. In this reaction, clearly indicate that 24 gram of magnesium is taken here. As a result, 2.016 gram of hydrogen is liberated, because magnesium having atomic mass, that is 24, hydrogen having molecular mass 2.016 gram. Suppose I want to produce 1.008 gram of hydrogen, then I want to ask you how much magnesium is needed to liberate 1.008 gram of hydrogen. Obviously, 12 gram of magnesium is needed to displace the hydrogen from H2SO4 and produce 1.008 gram of hydrogen. Remember an important point: what amount of magnesium is taken to react with H2SO4 and to produce 1.008 gram of hydrogen, that is called gram equivalent mass of magnesium. Similarly, what amount of magnesium is treated with the 1.008 gram of hydrogen to produce magnesium hydrate, that is called equivalent mass of magnesium. If the equivalent mass is expressed in gram, then that is called gram equivalent mass of magnesium. Similarly, what amount of magnesium is taken to react with the 8 gram of oxygen to produce magnesium oxide, that is called equivalent mass of magnesium. Similarly, what amount of magnesium is treated with the 35.5 gram of chlorine to produce magnesium chloride, that is called equivalent mass of magnesium. In terms of gram, it is called gram equivalent mass. From this example, it is clear that the equivalent mass of a substance is a number of parts by mass combine or displace 1.008 parts by mass of hydrogen or 35.5 parts by mass of chlorine or 8 parts
by mass of oxygen.
Remember an important point, equivalent mass has no unit. If the equivalent mass expressed in gram is called gram equivalent mass. Suppose I will take an example, 1.008 gram of hydrogen is liberated by 12 gram of magnesium. Therefore, I can write equivalent mass of magnesium equal to 12. Here I cannot write any unit, but if I want to find out the gram equivalent mass of magnesium, then I can write 12 gram. We know that equivalent mass of magnesium equal to 12. Therefore, I can write gram equivalent mass of magnesium equal to 12 gram. Suppose 40 gram of magnesium is given to you. Your aim to find out the number of equivalent mass. Then what will be your answer? Your answer is your number of equivalent mass equal to 48 by 12. That means I can write number of equivalent mass of magnesium equal to 3. From this data we can write a formula, number of equivalent mass equal to mass of the substance in gram divided by gram equivalent mass. Next I will give some rules to calculate the equivalent mass. First rule is your equivalent mass of an element equal to atomic mass divided by valency. Suppose I want to find out the equivalent mass of magnesium, then I can write equivalent mass of magnesium equal to atomic mass of magnesium divided by valency of magnesium. We know that atomic mass of magnesium is 24, valency of magnesium is 2. That means I can write equivalent mass of magnesium equal to 24 by 2 is equal to 12. Next rule is equivalent mass of an acid equal to molecular mass by basicity. Basicity means number of replaceable H plus ion from one molecule of an acid. For example, HCl gives H plus plus Cl minus. So the basicity of HCl equal to 1. Similarly, H2SO4 gives 2H plus SO4 2 minus. So the basicity of H2SO4 equal to 2. Suppose I will take another example, CH3COH gives CH3CO minus plus H plus. Look at that, here 4 hydrogen atoms are present, but here only one H plus is removed from this acid. So the basicity of this acid, that is called acetic acid, is 1. Suppose I want to find out the equivalent mass of HCl, then I can write equivalent mass of HCl equal to molecular mass of HCl divided by basicity. Molecular mass of HCl is 36.5, basicity of HCl is 1. So here I can write equivalent mass of HCl equal to 36.5 divided by 1 equal to 36.5. By this way, you can able to find out the equivalent mass of H2SO4 and equivalent mass of acetic acid, and also you can able to find out the equivalent mass of other acid. Next rule is equivalent mass of base. Equivalent mass of base equal to molecular mass of base divided by acidity. Acidity means number of replaceable OH minus ion from a molecule of base. For example, sodium hydroxide gives Na plus OH minus, so the acidity equal to 1 because here only one OH minus ion is displaced from sodium hydroxide. Like that, the acidity of calcium hydroxide is 2 because calcium hydroxide gives 2 OH minus ion. Similarly, when aluminum hydroxide undergoes dissociation, gives Al3 plus 3 OH minus. Since 3 OH minus ion are displaced from LOH thrice, so the acidity of LOH thrice is 3. Suppose I want to find out the equivalent mass of sodium hydroxide, then the equivalent mass of sodium hydroxide equal to molecular mass of sodium hydroxide divided by acidity. The molecular mass of sodium hydroxide is 40 and the acidity of sodium hydroxide is 1. So I can write equivalent mass of sodium hydroxide equal to 40 by 1 equal to 40. Next formula is equivalent mass of a salt equal to molecular mass of the salt divided by total positive or total negative charge. Suppose I want to find out the equivalent mass of sodium chloride. Then the equivalent mass of sodium chloride equal to molecular mass of sodium chloride divided by total positive charge or total negative charge. The molecular mass of sodium hydroxide is 58.5. When sodium chloride undergoes dissociation gives Na plus Cl minus. Here the total positive charge is 1, also total negative charge is also 1. In a salt, the total positive charge is equal to total negative charge. As your choice, you can put total positive charge or you can put total negative charge in this formula. So I can write equivalent mass of NaCl equal to 58.5 divided by 1 equal to 58.5. Next formula is equivalent mass of a radical equal to ionic mass divided by magnitude of charge. Suppose I want to find out the equivalent mass of SO4 2 minus. Then I can write equivalent mass of SO4 2 minus equal to ionic mass of SO4 2 minus divided by magnitude of charge. The ionic mass of SO4 2 minus is 96. Here the charge is 2 minus, so the magnitude of charge is 2. So I can write equivalent mass of SO4 2 minus equal to 96 divided by 2 equal to 48. Now I will explain about the calculation of equivalent mass of metal. First formula belongs to chloride method. According to chloride method, equivalent mass of a metal equal to weight of metal divided by weight of chlorine into 35.5. Now I want to solve a problem. The chloride of a metal contain 65% chlorine. Find the equivalent mass of the metal. let the weight of metal chloride is your 100 gram. Therefore, according to question, weight of chlorine equal to 65 gram, because here 65% chlorine is given. Therefore, weight of metal equal to 100 minus 65 equal to 35 gram. We know that equivalent mass of a metal equal to weight of metal divided by weight of chlorine into 35.5. Here the weight of metal is 35 gram, weight of chlorine is 65 gram. So I can write equivalent mass of a metal equal to weight of metal divided by weight of chlorine into 35.5 equal to 35 by 65 into 35.5. By solving, I can write equivalent mass of metal equal to 19.11. Next is your oxide method. According to oxide method, equivalent mass of a metal equal to weight of metal divided by weight of oxygen into 8. Now I want to solve a problem. An oxide of a metal contain 40% of oxygen. Find the equivalent mass of the metal. Here let the weight of metal oxide equal to 100 gram. According to question, weight of oxygen equal to 40 gram, because here 40% of oxygen is given. Therefore, weight of metal equal to 100 minus 40 equal to 60 gram. We know that equivalent mass of a metal equal to weight of metal divided by weight of oxygen into 8. Here weight of metal is 60 gram, weight of oxygen is 40 gram. Now put the value of weight of metal and weight of oxygen in this formula. Then I can write equivalent mass of a metal equal to weight of metal divided by weight of oxygen into 8 equal to 60 by 40 into 100. After solving, I can write equivalent mass of the metal is equal to 150. Next is your hydrate method. According to hydrate method, equivalent mass of a metal equal to weight of metal divided by weight of hydrogen into 1.008. You can solve many problems related to the hydrate method like chloride and oxide method. Next is your metal displacement method. According to metal displacement method, I can write W1 by W2 equal to E1 by E2. Here W1 and E1
are the
weight and equivalent mass of a metal respectively. On the other hand, W2 and E2 are the weight and equivalent mass of another metal respectively. By using this formula, you can able to solve many problems related to the metal displacement method. This is all about your equivalent mass. That is all about for this class. Thank you. Have a good day.